Now, what is your spanning tree protocol? Any idea? Oh. Your spanning tree protocol, it is a protocol that is used to avoid layer 2 loops. Why it is used? Used to avoid layer 2 loops. Okay. This is used to avoid layer 2 loops. Now, how a layer 2 loop will be created? See here. Let's consider you have three switches, switch 1, switch 2, and let's say switch 3. These are the three switches. Okay. And they are connected to each other. Let's say they are connected like this. Okay. This is your switch 1. Switch 2. And this is your switch 3. Okay, these are the three switches. And let's consider the interfaces. This is F0 by 1, F0 by 2. F0 by 1. This is F0 by 2. And here we have F0 by 2, F0 by 1. Okay. All right. Now consider there is a broadcast on switch 1. Okay. Let's consider there is a broadcast on your switch 1. Okay, let's say this is a ARP message. Okay, one PC is connected, want to communicate with some other PC. So initially we'll not have the MAC address, so we'll generate a ARP. And ARP message is what? Broadcast. So what your switch will do?
Send both sides.
Will send to both interfaces, F0 by 1 as well as F0 by 2. Correct? Okay. So I will change the color so that we can understand here. So your switch will send both sides. Okay. Now, first of all, we will consider this one. When this message is coming to switch 2. Okay, switch 2 will receive on F0 by 1. What kind of message it is? Broadcast. What your switch 2 will do? Will forward to switch 3. Correct? Switch 3 will receive this broadcast message. What switch 3 is going to do? Again forward to switch 1. Then what your switch 1 is going to do? Correct? Then switch 2 will keep on going. Do you see the loop? Okay. This is the one side loop. Second scenario, this is also broadcast. What your switch 3 is going to do? Forward to switch 2. Switch 2 will? Switch 1 will? Again forward to? Then again? Correct. So if you see here, there are two loops in your network. One is in this direction, anti-clockwise direction, and the second loop is in clockwise direction. There are two loops running in your network. Okay. And when there are loops in your network, this is extra traffic generated. This is extra traffic that is generated in your network. This is just one case when only one PC has generated. What if there are 100 PCs connected? Imagine the amount of traffic you will have in your network. That is the useless traffic, totally useless traffic. Okay. So to avoid these loops, we have the protocol STP. Okay. This is clear how the loops will be created and the loops will be avoided using STP. Okay. Now, how your STP is going to avoid the loop. Okay. So your STP will avoid the loop. Okay. STP avoid layer 2 loops by blocking redundant links, first of all, and the links that might create a loop. Okay, means basically it will be, you can say, by simply blocking the links. Okay, or by blocking a link. This is how ultimately your STP will block a link, the link that might create a loop. Okay, so how? STP, let's say if this link is blocked, okay, the link between switch 2 and switch 3 is blocked, right? So this link will not be present. This link will not be present. And if this link will not be present, that means if the traffic is coming to switch 2 will not be forwarded to switch 3, means this will be a kind of situation. Let me show you. Like this. Now, if the traffic is coming from switch 1, let's say if there is a broadcast on your switch 1. Okay, again, consider the same scenario. Now, if there is a broadcast, what will happen? Forward this side, forward this side. But now they do not have the link. Why? Because this link is blocked. The link, the cable is connected, but there will be no data transferred through this link. So if this message will not be forwarded this side and this message will not be forwarded this side, will there be any loop? No. There will be no loop. Is that clear? So STP will work by blocking a link here. Okay. Now, how your STP is going to make blocking decisions? Okay. How your STP will make the blocking decision that which link to block. Okay. So for that, let's consider the MAC address of the switches. Let's say here MAC address is AA. Here MAC address is BB. And here, let's say MAC address is CC. Okay. Now in STP, we have few things. Okay. There are few terminologies that are used.
Sir, I have a doubt. Sir, PC1, first time it will try to reach to PC2, then it will create a broadcast message. After getting the MAC address of PC2, the broadcast message will be reduced automatically, or
how it will be reduced? It will keep on running.
But next time PC1 have the MAC address of PC2.
But one time broadcast created, one time the broadcast has been created. Correct. Now it will keep on running here. How it will end? Okay. It will never end. That's why we want to avoid this thing. Okay. Now in STP, we have something called as STP priority. We have something called as STP priority. Okay. And by default, the priority is 32768. The default priority of your switches is 32768. Okay. This is the default priority. And STP priority range will start from, it is in multiple of 4096. Okay. So the range I will clarify in the practical. Okay, so let me keep it here. Okay, the total range I will clarify. It is in the multiple of 4096. Okay, now see. STP priority, then there is something called as bridge ID. What is bridge ID? Bridge ID is nothing but your priority plus MAC address. Okay, means it is written, how it is written in the form like this: priority colon MAC address. In this form it is written. This is your bridge ID. Let me change this symbol so that no confusion will happen. Okay, is that clear? Okay. Then there is something called as STP host. Okay, for each and every interface. Okay, let's say if your interface is fast Ethernet. Okay, if your interface is fast Ethernet, that means what will be the speed? 100 Mbps. For this, the cost will be 90. If your link is gigabit Ethernet, okay, the speed 1 Gbps, the cost equals to 2. Okay, not 2, 4. This is clear. These are the cost. This is clear. Now, if it is 10 Gbps link, the cost will be 2. Okay, but right now mostly we are going with this concept. Gigabit Ethernet. Okay. All right. Now, so if we calculate the cost here, okay, first of all, just type in the cost here. Between switch 1 and switch 2, 19, because fast Ethernet. Here also 19. Here also 19. This is clear. Okay. Now, how your switch 1 or how your STP will make the blocking decision that which switch or which link will be blocked. Okay. So first of all, a process will happen. Root bridge election. First of all, what will happen? Root bridge election. Now, what is a root bridge? Okay. Root bridge is the switch with the least priority. And see how root bridge will be elected. First of all, least priority will be checked. And then if priority is a tie, least MAC address will be checked. So first of all, root bridge election will happen. What are the criteria? Least priority. Okay. And if priority is a tie, then least MAC address. Okay. Now, in default case, what will happen? The priority will be equal. This will be 32768. This will be 32768. This will be 32768. Priority is equal. Correct. Now, MAC address will be checked. Which MAC address is the lowest? AA. Switch 1. So switch 1 will become what? Your root bridge. This is your root bridge. Okay. And if switch 1 became your root bridge, these other switches, they will become non-root bridge. They will become what? Non-root bridge. Switch 1 became the root bridge. The other switches became non-root bridge. This is clear? Okay. Then after what will happen? Second election. What will be the second election? All non-root bridge switches will elect root ports. Okay. They will elect root ports, in short, RP. Means here root port election will happen. Okay. Now about root ports, first of all, only available on non-root bridge switches. Root ports will only be present on your non-root bridge switches, will not be present on your root bridge. Okay. Then what will happen? Other thing, how to find the root bridge, how to find the root port. So these are least cost path to the root bridge. Least cost path to the root bridge. Okay. Now see. And one more thing, these are always in the forwarding state, means these are not blocked. Always in forwarding state. Okay, these are not blocked. Now see. Here. Switch 2 is the non-root bridge. Correct. Now switch 2 wants to reach the root bridge. Correct. So it will check that if I go through the interface F0 by 1, if I go through the port F0 by 1, what is my cost? 19. If I go through the interface F0 by 2, what will be my cost? 19 plus 19, total 38. And this side, which side I am having the least cost? F0 by 1. So F0 by 1 will become what? Root port. This port will become root port. Clear? Same way, your switch 3 will also check that if I'm going through F0 by 2, my cost is, and if I'm going through F0 by 1, my cost is 38. Which one is the lowest? F0 by 2. So my F0 by 2 will become what? Root port. This is clear? Okay. So means here the election happened and we came to know that these are what? This port is root port and also this port is root port. Root ports have been elected. Correct? Okay. Next election. Designated port election. Okay. Now, in short, we'll call it DP. Your designated port can be present on root bridge as well as non-root bridge. Okay, your designated port can be present on both the switches, can be on the root bridge also, can be on the non-root bridge also. First thing. Second thing, all ports directly connected to root port are designated port. All ports that are directly connected to your root ports that are designated port. Another thing you can see, all ports of a root bridge are designated port or DP in short. All ports on your root bridge are designated port. And one more point. Each link should have a designated port. On each and every link, there should be a designated port. And your designated ports are also not blocked. They are always in forwarding state. These ports are also not blocked. Okay. First thing, can be present on root bridge as well as non-root bridge. Can be on this switch also and these switches also. Then all ports directly connected to root port are designated port. Where are the root ports? Here and here. Which ports are directly connected? Switch one. Switch one ports are directly connected. Okay. So means this port is what? Designated port, as well as also this port is what? Designated port. So here your third point automatically fulfilled. All ports of your root bridge are designated port. Then each link should have a designated port. Okay, check this link. Does it have a designated port? This link have? What about this link? The between switch 1 and switch 3? Yes. Have a designated port. What about the link between switch 2 and switch 3? Does it have a designated port? No. So now we need to elect a designated port here. Okay. So if you want to elect last designated port, okay, last designated port, if you want to elect, how you will elect? Lowest path post. You will check what? To root bridge. If this is a tie, okay, you can say lowest send. Okay, who is going to forward the traffic? Then if this is a tie, then what you can do? Lowest sender bridge ID. Okay. Lowest sender bridge ID. Maximum times here you will get the answer. So see here. If switch 2 wants to check, okay, let's say switch 2 will say that no, I will be the designated port. I will make this port designated port. It will check. What is my cost? 38. Switch 3 will also check. What is the cost? 30. This is a tie. Next, what we need to check? Bridge ID. Okay, what will be the bridge ID here? 32768 colon BB. Correct? Here, CC. Priority equal MAC address. Which one is the least? BB. Obviously, this port will become what? Designated port. This port will become what? Designated port. Okay. Now see. So this port also became what?
Sir, going only in this direction, sir, it will not go in hand.
How? Through interface F0/2, and between F0/2 and F0/1, we have to make a decision that who will be the designated. Correct? So first of all, you will check the cost. So if the traffic is leaving through F0/2, it will reach RB. How? Using 38 cost. And through this interface, 38 cost. Cost is a tie. Then bridge IDs will come into picture. Okay. So priority is same. So MAC address is least, and it means the bridge ID is lower. And this will become what? Designated port. Clear? Now, once root port and designated port election has happened, then the final stage. Number 4, all ports other than root port and designated port are alternating ports. Okay, in short, AP. Okay, what are these APs? You simply say these blocked ports. Okay, these are the blocked ports. Means all the ports other than your root port and designated port will be blocked. Those will be the blocked port. Okay. So means which port will be in the blocked port? This one. This will be your EP. Okay.
So that is where looping gets stopped.
Hmm?
Loop will not happen because of
yes, because of this interface. Because this interface is down. Okay, not actually down, but this will be in the blocking state. Means will not let the traffic pass through this interface. So if the traffic will not pass through this interface, the loop will not happen. Is that clear? How your STP is blocking the ports? First of all, root bridge election. After root bridge election, root ports will be elected. Root bridge will be elected using least priority or least MAC address. Once root bridge has been elected, root ports will be elected. How? We will check all the non-root bridge switches. They will find the shortest path goes to the root bridge. So they will check the cost, and whatever is the least cost, they will select root ports. After root ports, designated ports. So all the ports of your switch, the root bridge switch will be designated port. And if there is no root bridge and we have to elect a designated port, first of all, we will check the cost. If cost is a tie, we'll check the priority. I mean bridge ID. Okay. And from there we will get your designated port, and remaining all the ports will be blocked ports. This is clear. Okay. All right. Now, before going to forwarding state, okay, any of the interface on the switch, if you connect a PC or something, see, let me open packet tracer. Your STP is by default configured in your switches. Okay, there is no special configuration you have to do, but you have to understand how it is working.
It's automatically.
Yeah, by default. This is one switch, second switch, third switch, correct? Now see. Okay. See, these ports are in orange color. Why? Because the election and everything is happening. That where will be the loops and everything. And these ports, before going to the forwarding state, they will transit through some stages. Okay, so we'll discuss those stages also, the port states. So it will take some time, you see here. Before coming to green, it's taking some time. And one of the ports will be blocked. See, one of the ports will be blocked. Okay. Okay, now see. So how they are deciding and how this election is happening, that we understood, how the blocking decision is making. But these ports, they are transiting through some states. What are those states? That we'll discuss. Okay. Okay, let's discuss it here. STP port states. Okay. The first is disables. The second is blocking. Third is listening. Fourth is learning. Fifth is forwarding. These are the states. Okay. In the disabled state. Okay, before this. Now, how they are making the decision, how they are communicating with each other. So for communication, they are using a special type of message. Okay. That message is known as BPDU. BPDU stands for Bridge Protocol Data Unit. Okay. So what is BPDU? It is the message that switches use to communicate with each other. Okay. And in the BPDU, what information they share? They share the information about bridge ID. Okay. Let's say, and share bridge ID. Is that clear? So using this message, they will communicate. So whenever a port is in blocking state, only your BPDU messages are passed. Nothing else. Okay. So initially the disabled state, the port is down. That means the port is simply down. No connection has been made to the port. Okay. And in case of disabled state, what will happen? No BPDU messages will be forwarded. If no BPDU means there will be no MAC address learning. MAC address will not be learned. And also no data frames will be forwarded. Okay. No BPDUs, no MAC address learning, no data forwarding. MAC address learning means your switch will store the MAC addresses in the CAM table. That part will not happen. In the blocking state, it will only forward BPDUs. Okay. BPDUs will be forwarded, but again, no MAC learning, no data forwarding. Okay. In the listening state, it will start listening and communicating with others. Okay. So it will send BPDU, receive BPDU, but again, no MAC, no data. Okay. Means kind of same stage you can see. No MAC, no data. In the learning state, it will allow BPDUs as well as MAC learning will be there. Okay, switches will learn the MAC addresses and populate the MAC address table, but still no data frames forwarding. Okay, and when the port is in forwarding state, it is a fully flashed working port, so it will forward everything. Okay, their BPDUs will also be forwarded. MAC learning will also be there, as well as data frames will also be forwarded. Is that clear? Now, in each and every state, it is spending some time. Okay, so when it is in forwarding state, already time done. When it is in disabled state, the timing is not started. Okay, so the actual time taken is in these three states: blocking, listening, and learning. Okay, so by default, in your blocking state, okay, in your blocking state, the switch or the port spans 20 seconds. In the listening state, your port spans 15 seconds. Okay. And in the learning state, your switch spans again 15 seconds. Okay. So in case of STP, by default, it will spend how much time? 50 seconds to come up. It will take a port to 50 seconds to come up. Okay. This is clear. This is the default time taken. Is that clear? Okay. Okay. Port states are done. Timers are done. Now see, let me show you. Okay, let's make it like this. So this will look similar to our topology. Now look similar. Correct? Okay. So this switch, you see both ports are on. So when this will happen? When this switch is the root bridge. Because if this switch is the root bridge, these will elect what? Root ports. So root ports will be these shortest path cost. Correct. And these are the designated ports. And all the root ports and designated ports, they are always in the forwarding state. So these links are forwarding state. Kind of, you can say, if you want to identify your root bridge, simply check that which switch has no blocking port. If you see this link is not blocked, this link is not blocked. That means this switch is. If you check about this switch, this link is blocked, this is not blocked. So this is not the root bridge. Check this one. This is blocked, this is not blocked, not the root bridge. Check this one. Both are not blocked. This is the root bridge. Okay. So how do we check? Let's say if I go to this switch, CLI, enable, command is show spanning tree. For VLAN 1, because VLAN 1 is the default VLAN, which protocol is enabled? So here it is showing you IEEE. That means STP is enabled. Okay. You will see two portions. One is the root ID and second is the bridge ID. One portion is root ID, second portion is bridge ID. Root ID portion is the information of root bridge. Bridge ID information is the information about self. Okay. This information is for the root bridge. And this information is about self. Okay. Check. What is the priority here? Now you can ask a question. Why 32769? I said 32768. Right. I said 32768. So basically what priority you see here, this is the combination of priority plus your VLAN ID. By default, what is the VLAN? 1. So 32768 plus 1. You can check here in the self information. It is saying 32769. Why? Because the actual priority is what? This one is the VLAN ID, system ID. Because we are talking about here VLAN 1. Is that clear? Okay.
If there is a VLAN 10.
Then it will add 10. Yes. Okay. Now see. The root ID portion, we have some things like we have priority, we have address, and then we will have that on which interface your root bridge is connected. And we have something called as hello time, maxis timer, and forward delay time. Okay. Priority, clear. MAC address of your root bridge. Here in this part, you will have the information that on which port root bridge is connected. Right now, we are just checking on the root bridge itself. So it is saying what? Means this switch is the root bridge. Okay. Then hello timer. So hello timer is the timer that how frequently the switches will send the BPDU message. So they will send every 2 seconds. Maxis timer, that if this switch is not receiving a BPDU from the neighbor, how long it will wait? 20 seconds. Forward delay timer, this is the duration that your switch port will spend in the listening and learning state. And that's why you see in by default listening and learning state, it will spend 15 seconds. If you make it 30 seconds, now in the listening also 30, learning also 30. Okay. Then priority of self, this is the root bridge information, right? And this is self information. So priority, this is the priority. MAC address, this is the MAC address. So you can see the MAC address is the same because this switch is itself is the root bridge. Then the same things. hello time, access timer, and everything. Okay. Now you see here the interfaces. What all the interfaces are connected? 0 by 1 and 0 by 2. Now we said root bridge, all the ports are designated ports. So you can see both ports are what? Designated in the forwarding state and how the cost 19. Why? Because these are the fast Ethernet interfaces. This is clear. Now let's check on another switch. If I check on switch 1, okay. On switch 1, on which port root bridge is connected? 0, 2, right? Show spanning tree. Let me get this side. Now check. Okay. This is the information about root bridge. This is the information about self. Correct. Priority, by default priority, same. Correct. Okay. This is the MAC address of your root bridge. This is the MAC address of switch 1. Compare 0009. 000C. Which one is the smaller? Because after 9 we will have A, B, C, right? So this is the larger one. So that's why this is the least MAC address. So became the root bridge. What is the cost to the root bridge? Through this port, cost will be what? 90. On which port it is connected? Port number 2. That is F0 by 2. Is it? Then the same things, hello time and everything. And you see, if you see here, this port, shortest path goes to the root bridge. So this will be become. And since here, this port is the block port, that means this port is. So F0 by 1, designated port. F0 by 2, root port. Clear? Forwarding state, cost is the 90. Clear? Now let me show you the switch 3. Here we will see the alternating port. Okay. Check. Root bridge information. This is self information. Priority by default equal. MAC address 00000. Who is the larger? So this will not become the root bridge. This is the root bridge. What is the cost to the root bridge? 90. On which port it is connected? Is it correct? Okay. Then check here. F0 by 1, 0 by 2. So according to this, this will be the root port, shortest path cost. And this is the blocking port. That means alternating port. See, F0 by 1 is the alternating port in the blocking state. F0 by 2, root port in the forwarding state. This is clear.
What are the types in the two?
These are P2P, port to port. Okay. This is clear. Okay. Now see. So what we saw here, we saw about timers. We saw about STP timers. First thing we saw, hello time. Correct. Hello time is what? How frequently BPDUs will be sent. And by default, it is 2 seconds. Default is what? 2 seconds. Then we have maxis timer. That is how long switch will store information without receiving a BPD. And by default, it is 20 seconds. Okay. And then we have forward delay timer. And a forward delay timer is how long, or you can say how much time the switch port will spend in listening and learning state. And by default, it is 15 seconds. Okay. Default is what? 15 seconds.
When we taking on that normal bridge, we will be only looking for root port and the designated port election only will be taking this right?
Where?
We switch to 163. When we
yes, root port and designated port. And if it is not designated port, it will be blocking.
Like if you go to the packages and switch again.
Okay. Yes.
Yeah. You went in change like
Yeah.
When it shows. So here when we are checking for root port and designated port, what conditions criteria
Same conditions, whatever we have discussed here. For root port, they will be available only on the non-root bridges. Okay. And they are the least cost path to the root bridge.
So here we don't see about the priority MAC address.
No, here we will not see. Because if this switch wants to reach the root bridge, it already has the option of the coast. Okay.
So here, how to check the cost? Like if you go to switch to again, show spanning tree.
See, by default, it will show you only this coast because this is the root port. It is not going to show you the other interface. It will not show you the.
But we were checking again that bridge like priority MAC address and all. You have to check only the cost.
Yeah. See, here it is telling you the cost. That what is the actual cost to reach the root bridge. Okay. All right. This is clear, the timers. Okay. And then after the timers. Now, when we discuss about the protocols, okay. So the protocols we can divide into two categories. The type of STP. So spanning tree protocols we can divide into two categories. Okay. First category, you can say the open standard protocols. Because Cisco will have most of the cases on protocols. Okay. So the first is STP. That is your simple spanning tree protocol. Okay. And if you want the IEEE number, IEEE 802.1d. Okay. Now, what is the thing with this particular protocol? That first of all, it will take 50 seconds to come up. It will take 50 seconds to come up, as well as only one STP for all the VLANs. For all your VLANs, only one STP. Kind of, you can say only one root bridge will be elected for all the VLANs. Okay. Second, now here the time was really big. It is taking 50 seconds, and every time you connect a cable, it will take 50 seconds to transfer the traffic. Okay. So for this purpose, a new protocol came up, RSTP. Okay. RSTP stands for Rapid STP. Simple. Rapid Spanning Tree Protocol.
So spanning tree, the VLAN doesn't matter. Any number of VLANs?
Yeah, only one root bridge.
Only one.
This is the open standard protocols we are talking about. Okay. So what happened? See here. Rapid
Yeah.
STP. Yes.
Inside the root bridge, there will be no cost for
That cost will be there. Cost will be there, definitely. But your root bridge does not have to calculate the cost for any non-root bridge. Okay. They will just calculate the cost for the ports. If the port is F0 by 1 fast Ethernet, cost is what? 19. Okay. See what you see here. What you are seeing here, these are the cost of these ports, not to reach the root bridge. To reach the root bridge, this is the actual cost. Okay, see, these both interfaces are what? Fast Ethernet. So the cost is what? 19. Correct. This is the cost that is to reach the root bridge.
But inside the root bridge, there will be no.
Yeah, there will be no cost. Why? Because itself is the root bridge. So why it will show you any cost here? See here. Not showing the cost, not showing on which interface it is connected. Why? Because itself is the root bridge. But these ports, these are fast Ethernet. So you will see the cost 19. Okay. So this is IEEE 802.1W. Sometimes may be asked or not asked. Here the time was reduced. That was few seconds, like 5 to 6 seconds it will take. Okay, but still the same issue, only one STP for all VLANs.
So one STP for all VLANs by default. By default.
No, this protocol rule. This is the behavior of protocol.
You can manually configure it.
If you configure STP, okay, in STP only one root bridge will be there. Doesn't matter how many VLANs you have. One root bridge will be there. Okay. Then this was the problem, because that means all the traffic has to pass through one switch only, through your root bridge only. Okay. Now what will happen? Or you can imagine the amount of traffic that switch will be forwarding, means the amount of CPU and memory uses. So to avoid that, they came up with the concept of MSTP, that is multiple STP. The IEEE code 802.1S. Okay. Now here the time was few seconds. Okay, but here the STP number of STP is increased. One STP for a group of VLANs. Now here we can create multiple STPs, but again we will create one STP for a group of, like if you have 100 VLANs, so for 1 to 10, one STP. Okay, 20 to 30 or 11 to 20, another STP, like that. So you can do that. Okay. These are the open standard protocol. Now, Cisco proprietary protocols. So when STP was designed, Cisco designed their own protocol with the name PVST plus. Okay. Name for VLAN spanning 3+. Okay. Now with the name itself suggests what is the concept per VLAN, means one STP for each and every VLAN. And that's why here in the switch you by default see in your switches by default this PVST plus protocol is running if you are having Cisco switches. And that's why you see here the calculation is for each and every VLAN. See here, it will start with VLAN number. If I create here VLAN 2 also, okay, and if I assign an interface in VLAN 2 also, then there will be separate calculation for VLAN 2. Okay. See here. So per VLAN
traffic still pass through the root bridge.
Yes.
Again, there will be more traffic.
That is, you can manipulate. Okay. That is, you can manipulate. You can manipulate that who will be the root bridge for VLAN 1, who will be the root bridge for VLAN 2. Manipulations we can do. Okay. But here by default, obviously by default, everything will be the same, whatever VLAN it is, right? then only one root bridge will be there. And that's why your PVST plus the default scenario we call as CST, common spanning tree, for all the VLANs. Since it is different VLAN configuration, but still the spanning tree will be common by default. So that is known as CST, common spanning tree. Okay. So it was similar to your STP only, was taking 50 seconds. Okay. But here, one STP for each VLAN. Okay. Now again the time. So when RSTP came out, Cisco also generated their own protocol. They said RPVST. That means rapid PVST. Now here the time reduced few seconds. Okay. And again, one STP for each VLAN. So by default, this is the protocol running. Okay, even the protocol you can change in your switch.
So for one spanning tree for each VLAN, it will have each VLAN will have one root bridge.
Yes, each VLAN. But by default case, you see, by default, the priority for each of the switch will be same. By default, the MAC address of each of the switch will be same. In default case, what will happen? Root bridge will be the same only. But if you go to the switch, okay, let me say if I create here VLAN 2.
So suppose it is every switch will have like 10 VLAN here. Like
You can
all
do
the
that.
10 VLAN will have the same rule.
Exactly. See, so okay, let me configure on all the switches.
So again, it works like this.
Same. Not a CCNA concept, but still let's check it.
So only thing difference is like the time gets reduced.
Yes, the timing is reduced. That's it. In Cisco and Open Standard, the timing is with the protocol same only, but difference is they did not have the per VLAN system, so they had to go with the MSTP. But Cisco was already going with the per VLAN system, so no need of MSTP in Cisco. Okay, but still you can configure.
So now the latest is
RPVST. Okay, now see. If I go here and check, show spanning tree. Right now it is showing VLAN 1. Why? Because we do not have any interface in the VLAN 2. Okay, so let me do one thing. Let me connect interfaces again. Okay. Let's connect more interface. Like this, interface numbers will get confused. Okay, this is F0/3, 0/3 here. Here also 0/3, 0/4, 4/4. Oh, now see. On this switch, which VLAN I created here? VLAN 2, right? Now see. Interface F0/4. Let me go with the range. Interface range F0/3 and 4. And both will be within the VLAN 2. Switchboard access VLAN 2. Done. Okay. Here also 3/4. Here also 3/4. Interface range F0/3 to 4. Switchboard access VLAN 2. Okay. On this switch also. Interface range F0/3 to 4. Switchboard access VLAN 2. You see it is saying VLAN mismatch is happening here. Now let's check. So you see now, for both the VLANs, these links are up. only this link is down. Same means that means for all the VLANs, this is the root bridge. Check. If I go here on this switch, and if I say show spanning tree, this is VLAN 1 configuration. For VLAN 1, this bridge is the root. For VLAN 2, again, this bridge is the root. Correct? Okay. And you see here priority. This time 32768 plus 2 will be added, 32770. Okay. Same things are there. Now let's say if I want to manipulate that, okay, I want that this switch 0 should be the root bridge for VLAN 2. Simply go to this switch and give the command. Spanning tree VLAN 2 root primary. Done. Now what will happen? The election will happen, entire election will happen again. Okay. Now see, this port is blocked. Okay. And if you go on this switch and check again. So earlier it was saying what? Okay. Not this one. This switch. Earlier it was saying for VLAN 2 also, what? This bridge is the root. Now check. So spanning tree. For VLAN 1, this bridge is the root. For VLAN 2, the root bridge is connected on F0 by 4. Check. On this switch F0 by 4, this is the root bridge. This is how you can manipulate. Okay. And how the root bridge was manipulated? Because of priority. Check the priority of, this is the priority of self. This is the priority of your root bridge. The priority got reduced. Okay. Is that clear?
For VLAN 2 alone, the priority got reduced in that switch.
Yes. And this is how you can manipulate. Is that clear?
Sir, there is separate link for each VLAN.
Yes.
Election will.
So obviously on one link, you can have one VLAN only. Correct. Otherwise, if you will keep one link, either VLAN 1 or VLAN 2, nothing else. Okay, so like this, we can manipulate. Is that clear? Okay. This is clear. The protocols are clear. By default, your protocol is what? PVST. If you want to change it to RPVST, okay, simply how you can run, see. You will say spanning tree, see here. Mode, you have the option PVST and RPVST. By default, PVST is running for VLAN spanning tree. If you go with the RPVST, okay. Okay, now check. Show spanning tree. It will show you RSTP. Okay. This is clear. So this is
irrespective of models, by default it just go only PVS.
PVST by default. Doesn't matter which model. Okay. But you can manipulate. Okay. After that, what other things?
Sir, in simulink we can run multiple VLAN.
Trunk.
Yeah, done only.
We only with trunk.
But the only single link that trunk code, you can run multiple VLANs. But whether I want to send my all traffic from VLAN 1 to switch 1.
In that case, see, if you are creating trunk link, let's say as of now, let me show you. Let's say this interface gone, and this interface gone, and also this interface gone. Now this is okay. Wrong interface. Okay. Now what I'm going to do, I'm going to configure a trunk. Okay. interface range F0 by 1 to 2. Okay, switch port mode. Interface range F0 by 1 to 2, switch port mode. Interface range F0 by 1 to 2, switch port mode. Done. Now we have two VLANs running here. Okay, check.
There is no blocking port.
Why blocking? Why it will block? See here. Show spanning tree. Show. Show spanning tree. Our protocol also changed. Did I change on this router? The protocol. See here. Now what is happening here? For VLAN 2, these are the designated port, has to be in the forwarding. And for VLAN 1, means for if the traffic is for VLAN 1, the traffic will not be passed through this interface. So it will automatically segregate based on the VLAN ID, because there will be a tag. .1q header will have a tag that for which VLAN this traffic is, and based on that they will segregate the traffic.
VLAN 1 it will never forward traffic to past.
Hmm?
For VLAN 1 traffic, it will never forward through this port.
Yes, it will never forward through this port. Concept will remain same only. Concept will remain same only. Only the thing is that instead of using two ports, you are using one port and using a trunk. Clear?
But still the two VLANs like but still the blocking port will be only one port.
Yeah, for see, it is saying right on this port is blocked for VLAN 1.
Only blocking for only VLAN 1 for both VLAN.
No, because for VLAN 1, this is the root bridge, and VLAN 2, we have created this one as the root bridge. Yeah, we have manually. If you see here, the priority and everything still changed. Okay, it is saying right, this bridge is the root for VLAN 2. For VLAN 1, it is connected on F0 by 2 here, this one.
Since we manually
Yeah.
it, so
Yes. If you want it to be blocked, in that case, you can say, see what command we gave, no spanning tree, VLAN 2 root primary.
the same concept we have to apply for the different VLAN.
Correct, correct. Now see the priority is same. Now this port will also be blocked. Okay, by default, there is no selection. It will take some time.
So one VLAN we have to treat as one spanning tree, and another VLAN we have to separately treat it as another spanning tree.
Correct.
And that time we have to.
That will happen. Yes. Okay. Now see. These all things are done. Now, what happens? Let's say, for example, someday you want to add one more switch in the network, or let's say there is a employee who want to add in their own network. Means there is an unwanted switch in your network. Okay, and let's say that switch has lower priority than your actual root bridge. What will happen? The particular switch will send BPDUs. In the BPDU, bridge ID will be there. In the bridge ID, lower priority will be there. So the unwanted switch might become what? Root bridge. And if the unwanted switch will become root bridge, all the calculation of root port, designated port will happen according to that switch. Correct? And if it will happen, your blocking ports will change. Your blocking ports will change. Means your spanning tree topology will change. And being a network admin, this is not a good news for you. Changing of spanning tree topology. Is that clear? So how to avoid these things? How to prevent an unwanted switch from becoming a root bridge? Okay. So for that, we have two concepts. One is BPDU guard. Okay. One concept is BPDU guard. If you enable BPDU guard on an interface, okay, it will wait for a BPDU. Okay. And if it receives a BPDU guard on that interface, what it is going to do? It is going to shut down that port, block that port. Okay. So you say if BPDU guard is enabled, interface, it will wait for BPDUs. And if it receives a BPDU, and if a BPDU is received, then STP will, or not STP, the BPDU guard will block that port. Okay. Now, in general cases, what will happen where you will enable BPDU guard? You will enable BPDU guard on the interfaces. Okay. You will enable BPDU guard on the interfaces where you have enabled the port fast. There is one more concept, port fast. See what happens. Generally, when you connect a PC to a switch, is there any chance of loop between the switch and PC? That is a single link, no chance of loop. So, do we need to wait for 50 seconds? No, right? So, we want that the interface, as soon as I connect a PC, the interface should come up. Okay, so on that port, I will enable port fast. Okay, so if port fast is enabled on the interface, if port fast is enabled on an interface, the interface will instantly come up, or I say instantly move to forwarding state. No listening, no learning, no blocking, nothing. Directly move to forwarding state. How do you enable port fast? Go to the interface, interface name, and give the command spanning tree. Oh, the tab doesn't work. Spanning tree port fast. Okay, this is the command to enable. Now, if you have enabled port fast, your interface will instantly come up. So on port fast interfaces, this BPDU guard and BPDU filter are enabled. Okay. There is another thing, BPDU filter.
Before the port fast command also we can connect these.
Yes, we can connect, but it will take 50 seconds. See, by default, if I go here and if I try to connect a PC, see, my port will remain in blocking, listening, learning, all that states. It will go through that, this particular portion. Okay. See, still orange. But if I go here on the interface F0 by 3, interface F0 by 3, sorry, not F0 by 2. And if I give the command spanning tree port fast, now see. Directly. Okay. How do you enable BPDU guard? Spanning tree. Do you see BPDU guard option? BPDU guard enable. BPDU guard will be enabled on this interface.
Secure purpose, like so no one can
unwanted switch cannot be there. Yes.
With that BPDU guard, if you enable only port fast,
port will instantly come up. The switch will send BPDU and will become the root bridge. And if you want that a switch should not become like your root, any unwanted switch, accidentally it should not become a root bridge. You can enable root guard also. There is lots of options. How do you enable? Simply say spanning tree guard root. Root guard also enabled.
The root bridge we have enabled.
This command you have to give on the root bridge. This command you have to give on the root bridge. So it will start guarding the root bridge. Okay. You can set the priority also, and it ranges between 0 to 61440. Okay, and in the increment of 4096. So this is the range what we were discussing here. Okay, BPDU filter, I'll discuss what the range first. 0 till 61440. Okay, in multiple of 4096. Okay, in short, I'll say in multiple of 4096. Okay. Now, what is the BPDU filter? BPDU guard will just wait for incoming BPDU. Okay, your BPDU filter will filter both the sides. Okay, if BPDU filter is enabled, then it will block both incoming and outgoing BPDU. Okay, if a BPDU is received, then it will block the BPDU and remove the port fast feature. On the interface. Automatically will remove the port fast feature. Is that clear? Clear? Then there is something called as root guard. These all are CCNP concept. But still, when we are discussing, let's just discuss this.
Why just remove the port fast feature?
So that before, see what will happen. This BPDU guard and BPDU filter. Okay, these two things. First of all, these are used to avoid unwanted switch. Okay, so for guarding the root, we will enable root guard so that accidentally no other switch should become root guard. Okay, these will be helpful in avoiding the loops. Let's say there is an employee who is connecting to this network. Instead of this PC, what he does? Let's say, for example, instead of this PC, he connects to a switch. Okay, this is the company PC, but he connected to a switch. And for getting higher bandwidth, let's say between the higher communication, he will connect. See, I enabled what? If you see BPDU guard, I enabled, right? Now see, this port has been blocked. And if you see here, the log will also be generated. Native VLAN mismatch. See here, the log. Earlier, when I show you that how to configure BPDU guard, I configured BPDU guard on this interface, right? Now what it is saying, see, received BPDU on interface, fast Ethernet 03 with BPDU guard enabled, and what it is doing? Disabling the port. So these are used to avoid the loops.
That is a BPDU filter.
Same thing. Instead of BPDU guard, you can go with the BPDU filter. Yeah, but BPDU filter will not disable the port. It will not disable the port. Instead, it will just block the BPDU and remove the post fast feature. So that again, what will happen? All the HTTP process will happen. Okay. So that the port will not instantly go up. Loop will be checked.
Loop will be checked, but no issues will happen.
Yeah, no issues will happen. And for preventing root, we already have the root guard. Okay. So root guard, you can say, used to prevent unwanted change of progression. Okay. And how do you do that? Go to the interface. Your interface name. Spanning tree guard. Okay,
Root card we have to configure only on
root bridge. Yeah, root bridge.
That's why it will remain.
So it will remain root bridge. Even if it is receiving a BPD with a higher one, still don't care. Okay.